Hello, boys and girls, and welcome to another episode of your favorite algorithm channel. My name is Ryan Powers, and today I'm going to be taking you through LeetCode 31, next permutation. So let's introduce the problem. Implement next permutation, which rearranges numbers into the lexicographically next greater permutation of numbers. So we're going to have an array, and there are going to be numbers in that array. And if we were to read that array like it was a number, what we want to do is return the next number. Like, what would be the next number in the sequence, the next greatest number? So if such arrangement is not possible, it must rearrange it as the lowest possible order, i.e. sorted in ascending order. So if it is the greatest possible number, if the numbers are in descending order, like if we had 5, 4, 3, 2, 1, well, there's no greater number than 5 possible rearrangement of the numbers. 5, 4, 3, 2, 1, that makes a greater number. So we would return 1, 2, 3, 4, 5, right? The lowest number. The replacement must be in place and use only constant extra memory. So we can't use any kind of data structure like doing heap sort or something like that. We can't use any kind of data structure to like rearrange all of our numbers. We need to do in place sort. So we need to sort the numbers in place. So we are modifying the input here. So let's look at some of the examples here. So here it says 1, 2, 3 is going to be 1, 3, 2. So that would be the next greatest number. 3, 2, 1 would be 1, 2, 3 because there's not a greater number than 3, 2, 1 possible. So we would return 1, 2, 3. And then 1, 1, 5 becomes 1, 5, 1. So we're just swapping the 5 with the 1 there. Anyway, so this isn't a terribly difficult problem to reason about. You can look at the input array and you could rearrange the numbers yourself to the next greater number. I think we could all figure that part of it out. But the difficult part of this problem is, how do we do this efficiently? First of all, how do we do this efficiently? We should be doing this in n time. That's just a little hint for you. But the optimal solution to this problem is in n time. And we should be doing this in place, right? We should be swapping the indices of the array in such a way that it returns to us the next greater permutation. And we need to do this in a systematic way so that we can do it on any input. So that's my challenge to you this morning, or LeetCode's challenge to me, which I am then forwarding on to you, is to find the next permutation. So as always, I suggest that you try to solve the problem first on your own. And if you get stuck, or you just want to see how I solve the problem, then check out the video. Otherwise, if you're ready to get started, come with me to the whiteboard. Okay, on the screen here, I have an array with some numbers in it, 1, 2, 5, 4, and 3. And what we want to do is we want to, return the next permutation of numbers. Well, how do we do that? Well, just logically, what we want to do is we want to make the lowest possible change that we can, right? We want to return the next number. So how do we do that? Well, we want to start from the back here. And what we're going to do is we're just going to look at the next number. We're going to say, hey, is this number bigger than that number? No, it's not. Well, then swapping these would not make the number bigger. So we don't want to do that. And we can look then at the next number and then compare it with the number before it. And we can ask the same question. Excuse me. Is this number bigger? No, it's not. So it won't make the number any bigger. And then we'll go to the next index. We'll do the same thing. Well, 5 is bigger than 2. So if we swap these, if we put 5 here and 2 here, right? Now that would make the number bigger. But that would make the number too big, right? Because that's not the next greatest number. The next greatest number, we found the index where we can swap. But now what we need to do is we need to take the lowest possible number to the right of this number that will make the entire number bigger, right? So what the final answer is actually going to be 1, 3, 2, 4, and 5, right? That's the next permutation. That is the next arrangement of these numbers that is going to give us the result that we want. Well, how do we systematically do that? Well, what do we know about this input here? Well, we're decrementing our way from the back through this array, and what we're doing is we're checking to see if the number is bigger than the number after, right? Until we hit this point. What does that tell us? Well, that tells us that every number to the right of 2 is sorted, right? This is sorted. This is sorted in descending order, right? Or sorry, yes, descending order from left to right. So that means that we can actually swap these, right? We can swap these numbers here and rearrange them so that they're in ascending order, which is what we want, right? And then we can make this swap. So that's kind of what we're trying to do. So the steps of this algorithm are to one, iterate from the back, checking for the next number that or the first descending number, which is going to be this number right here. And then what we want to do is then swap these, right, until it's in ascending order, and then go back this way and find the first number that's bigger, right? So let's kind of quickly just walk through that process. So we check this number, it's not bigger. Check this number, it's not bigger. We check this number, it is bigger. So this is what we so now we want to sort this part, right? So we would then sort by swapping these indices. So we'd swap 5 and 3. So then we put 3 here and 5 here. And then we would swap, 4 with itself. You can't really do that, but that's how that would work. And then what we'd want to do is start checking for the next larger number, right? So we would check these two and we would say, yep, 3 is larger than 2. So now we'd want to swap those. And that would give us our final answer. So it'd be 1, 3, 2, 4, and 5. So this is kind of the entire algorithm. I mean, it's the hard part of this is just all these little steps, right? There's a lot of places for things to go wrong. So it might throw you off when you're trying to solve this. You're like, I have the answer to this problem, but when you try to implement it, you might have a pointer off or whatever. But there's a lot of moving parts here. So I think that's a challenging part. But what's the time complexity of this? Well, kind of gave it away in the beginning, but it is order n, right? Because in the worst case, what we're going to do is we're going to iterate all the way to the front and find that these numbers are actually in reverse order. And then we're going to swap every index, right? And so in the worst case, we're going to do 2 passes. We're going to do 2 total passes on this array. And so our time complexity is big O of 2 to the n, or 2, not 2 to the n, 2n, right? Which is just going to be n. So that's the time complexity. And this is kind of now that we know the strategy of how we're going to solve this problem, let's see what it looks like in code. To code this function, we're going to use 2 helper functions. We're going to use this reverse helper function, and also we're going to use a swap helper function. And we're going to use those 2 functions to help us build out the logic for this next permutation algorithm that we're going to be constructing here. So what's the first thing that we want to do? Well, we want to iterate from the back, and we want to look for the first decreasing number. So how can we do that? Well, the first thing we can do is we can initialize I to be 0. Create a pointer, sorry, not 0. We actually want the last index in the array. So we'll initialize it to be nums.length -1. And we'll just say that while the number in front of me, so that would be nums at I -1, while the number in front of me is greater than the number behind me, so that's going to be nums at I, then we want to keep looking. So to keep looking, we just need to decrement I, so we'll do I -. And then after that, we want to do 2 things. So we want to reverse, right? And then we also want to swap. So to do the reverse, we'll just pass in nums. And then we need to pass in the starting index that we want to start reversing from, which is I. And then we want to pass in the number that we want to compare with. So that's just going to be nums at I -1. So this reverse function actually does 2 things. So it reverses all the numbers to the right of the number that we found. swapping those indices. And then it's also because when we swap those values, we're going to be coming across those numbers in descending order. So that gives us an opportunity to look at all the indices that are to the right of the number that we want to swap with and take the lowest number that's higher than the number we want to swap with. So reverse is actually going to return the index of that number to us. So we'll store that in a variable and we'll call it swap index. We'll set swap index to be the result of calling reverse with these values. And that's going to return the swap index to us. Now, when do we want to swap? Well, we only want to swap if swap index does not equal null. So if swap index equals null, that means that we never came across a value that was greater than the number we want to swap with. And if that's the case, we don't want to swap anything. Because that means that that's the lowest possible value, right? So, but anyways, if we do come across a number that we want to swap with, we want to pass in nums, and we want to pass in I minus 1, because that's the number we want to swap with. And then we'll pass in the swap index. And then we'll just return nums at the end. So that's kind of the higher level logic of this problem. These are the 3 steps we need to take to accomplish this algorithm. And now we just need to build out these helper functions that will allow us to do that. So let's just take care of the swap function first, because that one's a little simpler. So we'll just store a variable temp so we'll store one of the values in a variable temp. It doesn't matter which one, but we just want a pointer to one of those values because we're going to overwrite one of them right here. So we'll take the array at index I and we'll set it equal to array at j. And we'll take the array at j and we'll set it equal to the temp, to the variable temp that we stored, the const temp that we stored the value of the array I in. So that takes care of the swapping. So now this is kind of where all the more complicated logic is coming into this function. And so, like I said before, we want to do 2 things. We want to reverse all the numbers to the right of the number that we're passing in. And then we also want to check those values that we're coming across in descending order, updating a swap value at each iteration. So let's start with the pointer bits first. So we want a pointer to the end of the array, which is going to be array.length -1. And then we also want to copy the start, right? Because we want to decrement the start swapping those values, but we also want to keep track of where we started swapping from, right? Because that's the point up until we need to check for the swap value. So we'll copy that index start so we can keep track of our pointers. We're going to be keeping track of 3 pointers here, 3 pointers. And then we also want to keep track of the swap index, and we'll initialize that to null like we said before. And then we also want to initialize a swap value. And what do we want to initialize the swap value to? Well, we should initialize the swap value to infinity. And why should we do that? Well, we want any number that's greater than the number we're passing in, right? We want to assign it to any number that's greater than the number we're passing in. So if we set it to infinity, that will grab any number greater than the number we're passing in. And then at each iteration, we want to check to see if the number we're coming across falls between these 2 values, right? Because we want the lowest number that's higher than the number we're passing in. So by reassigning val or swap value at each iteration and taking that index, we will effectively be getting the lowest number that's higher than num that we're passing. So how are we going to do this? Well, you guessed it. We're going to make another while loop. And how long do we want to look for? Well, we want to look while start is less than or equal to end, because we're going to be decrementing end. Start's going to stay the same. So once we hit start, we know we're done. And then we need to do the 2 things inside of this while loop. We need to first check to see if we need to swap. So if I is less than end, then we want to swap. So we'll call swap, passing in nums, and we'll pass in I and end. So I'll take care of the swapping bit. And then we want to check to see if we need to update the swap value. So like we said before, how do we know we need to update the swap value? Well, if the number we're coming across is between num and the swap value, we want to update it. So we'll check that by checking the array end to see if it's greater if it's greater than num. And we also need to make sure that this number, the array at end, is less than or equal to swap value. So why equal to? Well, because we want the farthest left number, right? So even if those are equal, then we want to update the index. So we'll do we'll update the swap values inside of here. So we'll say that swap value is equal to the array at that index at end, and then we'll say that the swap index is equal to end, updating that swap pointer. So then after this, we want to, of course, decrement end and then increment I. And at the end, we want to return the swap index. So let's just do a quick little recap here. So inside of this next permutation function, what we're doing is we're iterating from the back, right? And we're checking for the first decreasing number, which is this part right here. And then we're reversing all the numbers to the right to make sure that we're rearranging them in the lowest possible number arrangement. And at the same time, we're also going to be, as we're swapping those values, checking for the lowest number that's higher than the index of the number that we found that we need to swap with. And then finally, we're checking to see if the swap index does not equal null, then we're going to swap, right? And we wrote our helper functions here. This is a helper function help us swap, and then this is the reverse function here that does that where we set up the two variables and the pointers where we want to be checking to keeping track of where we need to swap, as well as tracking our swap value. And we're looping through here and doing that work. So let's just see how we did. Okay, I got an error. Let's check that out. Nums is not defined, line 19. Okay. Nums, yep, because I passed an array. Let's try this again. Okay. Let's see. Oh, so I also needed to make sure that we also need to keep moving if it's, we need to find the first decreasing number, right? So we need to do greater than or equal to. Try this one more time. And we got it. Great, finally. So I've been getting these really crappy results from LeetCode lately. So my new thing is I go and I check out the results and I just rip the best solution and I see if they're better than me. You know, I mean, I don't know what LeetCode's doing to me right now, but I really don't like it. Every time I run anything, it just makes it look like I don't know what I'm doing. Which is terrible when you're creating videos to try to help educate people. So we're going to just rip this best solution on LeetCode, and we're going to run it. We're going to run it. We're going to run it just to check to see if it's better than what we did. Okay, so we'll paste that in here. Awesome. And let's just see how awesome the best solution on LeetCode is. Oh, great. It's worse than ours. Perfect. I'm only going to do it one time. I don't want to see anything different. That worked out great. Anyways, my name is Ryan. I hope you enjoyed this video. This is kind of a tricky problem because it involves a lot of moving parts, which I don't ever really find super fun because there's always a lot of bugs. I mean, you can see like I've got like runtime errors, wrong answers, like all over the place here while I was practicing for this. So it is kind of it isn't really a hard problem when you just drawing it out. You're like, okay, just move these numbers around. But doing it in a systematic way can be challenging just to get the logic of the problem right. So I believe we did go over the time complexity, but the time complexity of this problem is big O of n. It's actually 2n, right? Because in the worst case, we would go all the way through and all the way back through the array, so we'd have to loop through it 2 times. The space complexity is constant. We're not using any extra space per the rules of this LeetCode problem. Anyways, I hope you enjoyed the video. I hope you learned something, and I hope to see you in the next one.